in the morning for you, and we are very grateful for you to be taking this session for our participants. Uh, so, I'll just give a brief introduction, though I think most of the uh, people over here, participants, know you, but still. No, Dr. Nikunj, is the slide visible?
Yes,
That,
madam.
okay.
It is visible. Yes.
Got it. So today's session is by Professor Amit Seth. He's the founding director of the Artificial Intelligence Institute, University of South Carolina, USA. And the topic of his talk today is robust and trustworthy AI for mission critical and enterprise AI applications, neurosymbolic, custom, compact, and agile AI models and co-pilots. So, Professor Amit Seth is an educator, researcher, and entrepreneur. He's the NCR Chair and Professor of Computer Science and Engineering. As a founding director of the university wide AI Institute at the University of South Carolina, he guided its growth to nearly 50 researchers in its first 4 years. He is a fellow of IEEE, AAAI, AAAS, ACM, and AIA. His awards include IEEE CSW Wallace McDowell and IEEE TVS VC Research Innovation Awards. He is one of the highly cited computer scientists worldwide with an H index of 120, more than 61,000 citations, and an I100 index of greater than 144. He has co-founded 4 companies, including the first semantic search company in 1999 that pioneered technology similar to what is found today in Google Semantic Search and Knowledge Graph, EZDI, which developed knowledge-infused clinical NLP and Cognovi Labs at the intersection of emotion and AI. He is particularly proud of the success of his more than 45 PhD advisees and postdocs in academia, industry research, and entrepreneurship. So, we welcome you to this session and we are very thankful that you could join us today. So, over to you, sir.
Thank you very much. It was wonderful to connect to you. I'm glad to see this number of people who have signed up. May I briefly know who is the audience? Are these LMNIIT students, and are they all in computer science, or what is, who am I talking to?
Okay, so they are faculty members from Technical Institute Span India.
Oh, okay.
Apart from, yes, most of them would be having a background of computer science, but there are some with electronics or mechanical background as well. Then we have research scholars. We also have officers from DRDO organization, the defense organization, DRDO. So it's like a diverse audience. And I think they are probably all having some basics of deep learning.
Okay. For my for the DRDO friends, I actually have a white paper on sovereign AI for strategic autonomy. The idea came to me after my meeting with the Prime Minister and my keynote at the third annual Chief Secretaries meeting on, I think it's just, on 27th of December last year.
Okay.
And so, India has a lot of opportunity and challenge in making sure that the AI is completely owned by, like any other technology, but AI is certainly owned by the country and secure and other issues. Of course, today I'm not talking about those issues, but feel free to reach out to me for my concept paper. Today's talk is, let's see if I can. I see. Give me 1 second. I'll have to transfer the talk to another. Yeah, okay, that should do. Okay, all right. Now go to share. Okay. Can you see this? Ah, now it is showing up.
Yes, now it's visible.
Okay. Now is oh, this is the window. Huh. Okay. So we're going to talk about a robust, intelligent, and trustworthy AI. People would expect that AI is intelligent, but actually, not exactly. Not all the AI, not current AI, or there are different facets of um AI that could be more intelligent. And let me start with a little bit of introduction of what my team does, what we do at AI Institute. So we work on a whole area of a whole number of areas of AI. You can see them in the uh, inner ellipse. And today I'm going to largely talk about the topics in the red. I'll say a little bit about generative AI also, since there is time. I believe you've given me up to 90 minutes. Am I right?
Yes, Professor Sid. Yes.
Yeah. Okay. So I'll little touch upon very little bit about generative AI, because this is so important. This is something that people talk about the most, and I want to make connection between the most popular and state of the art AI with the next generation of AI that we are working on. The kind of topics that at least I feel will become very important. In the process, you see on the outer ellipse a whole lot of applications, and I have well, I think I did not put defense intelligence, but I have. I'll today talk about just a few of them by way of examples. But you can see that one important thing to note here is that AI has such a wide application. It's a very core and basic technology, just like software is a very basic technology. So AI, people are talking about AI operating system, and it's going to be, is use is currently widespread in certain type of work, and will be widespread in the future, in 5, 4, 5, 6 years. Uh, this is my this is the AI Institute. You can see on the top left, this is the group of people who moved with me from Wright State University to when we moved to Georgia, sorry, to South Carolina. And in fact, that even includes one alumnus who was visiting me from Samsung Research. And then over the period of time, we have grown substantially. On the bottom right was the first PhD student who graduated from here. He's a faculty at UMBC. Um, okay. Uh, the the talk will be today about overview of the challenges in generative AI, and motivation for robust and trustworthy AI. And then I'll briefly deal with some of the challenges in generative AI, and then we will go on to robust and trustworthy AI. And within that, we are trying to look at all of you probably are aware of the AI models like the GPT behind Chat GPT or Llama 3. So those are the large language models. I believe that we we are moving towards a different alternative, and very soon you'll see many more different models as we go along. So let's look at what's happening today in generative AI and where we are. So US's defense agency DARPA, which funds a good bit of research. In fact, the internet came out because of DARPA. Um, has talked about, and most people recognize AI in three phases. On the left hand side, you see AI called symbolic AI. You used to have rules and logic and expert systems. Then came machine learning and other forms of statistical machine learning. So you had traditional machine learning, you had deep learning, and the deep learning had quite a few successes. So we have seen, for example, radiology. The ability of today's radiology screening system is on the average better than a human expert radiologist. So interpretation may not be as good, but classification is extremely high quality. And there are many other success stories, protein folding, and in chemistry and drug development. So that is fantastic. And then there is this latest is the evolution of large language models. So the idea has been to collect very huge amount of data from anywhere you can find it, and then a let a technique like transform let loose, and then you get from it the highly huge parametric space, which is exceptionally good at some of the things it does. Now it comes with a lot of challenges and problems, so we'll discuss a little bit of those challenges and problems, and then we'll move on to the kind of application for which LLMs are not the best solutions, and that we need different kinds of model and different types of not just the model but the AI systems themselves, because humans don't just interact with AI model, they interact with the system. Typically, most of you would not be using GPT, you'll be using Chat GPT, and Chat GPT is a collection of systems, collection of things, and you call that AI system. And how do you make them appropriate for certain kind of complex, mission critical, and enterprise applications? That is what we're going to talk about today. So at a very some of you who know the current generative AI know that the current language models essentially are predicting the next word, and what is the most likely next word. And essentially, to find that, they look into this parametric space you see on the right hand side, and they essentially predict which word would be the next. This is a very high dimensional space, bit hard to visualize for us. This is also called distributional semantics, and in the words that are preceding can give the model the context it needs. Now, this technology has become exceptionally good at a certain kind of task. I'm going to characterize them as information assistant tasks. So you're doing question answering, you are doing coding, you are doing editing, you are doing content generation, you are helping you using it to generate your email, even to respond to an email. So the interesting thing is that it is possible that your email is read automatically and your answer is given automatically. So the machine can talk to each other, humans can stay out of the way, or at least just be a supervisor. And so that's a strange new world that we are going towards. And this technology has impressed so many of us. So for the thing that it for the things that it does well, it's amazing and it's exceptional. But it has a lot of problems. I'm going to talk about it. and so we have to be careful. And the second thing is that there are class of applications. I would call them decision support assistant applications that require planning, causality, cognition, reasoning. These things are not served well by generative AI. Generative AI, large language model as we know today, are not capable of serving them. They just don't it's just a different purpose, and that there are a lot of problems if you were to try to use language models for such applications. In the context, the there was a paper that you can see in the blue, consent in crisis, rapid decline of AI data commons. One problem that was identified is that the models on which this is trained on is uses vast amount of data that is collected on the web. But the problem is that there is a lot of AI generated data now. There's a lot of data, there's a lot of junk. That is the amount of AI generated data, which I'll talk about briefly later on, is growing, and so that is contaminating this content, and that can lead to poor quality of results. Now, there's another important very consideration. You see that picture. Darren Acemoglu is the one of the 3 Nobel Prize winner in economics this year. Now he was talking about whether the current AI is relevant to high and useful for high value business or industry use cases that impact productivity. And he presented statistics that AI can do only 5% of the jobs. That means there is a lot of scope. Not that 100% of jobs needs to be done by AI, but there's a lot of scope for developing AI that can do more of the task. Here was in just about a month ago, Gartner came out with statistics that today just about 1% of the AI models, generative AI models, are used by enterprises. And there's some other statistics that talks about some other number, but it's very low. And within 3 years, there'll be other models that will come up to support high value applications. An example could be clinician decision support. You could not be making mistakes, otherwise you'll have a human, and create personalized treatment plan, where you have to provide a lot of contextual information about a human. And another statistics that a lot of Gen AI project will be abandoned due to data issue, risk, cost, and unclear value. So, for example, in healthcare projects, poor decision support coverage due to lack of domain expertise, adverse outcome due to internet inherent model properties like hallucination, contamination, and high cost of AI model deployment in clinical settings. Also, privacy, because for example, if you're using ChatGPT, all of that data, all of your conversations go to OpenAI. So here are some of the issues that have been noticed. ChatGPT showed only 50% accuracy in medical queries, raising concern about trustworthiness in clinical issue. There is, when you are applying, let's say, in clinical application, doctors have to follow clinical guidelines, and LLMs rely on outdated and incomplete information, and you may have medical or clinical guideline that doctors have to follow that may not be the language model does not have the specific guideline that an asthma specialist or a cardiovascular interventional cardiologist would use. Now, if you are in a medical practice, you have to follow those guidelines. You do not have the option, otherwise you will hurt human as well as risk litigation. Domain specific expertise is very important, and there can be bias and other harmful outcomes. What has been happening is that uh, AI use, particular generative AI use, is been creating a bunch of problems. Look at the headlines on the left hand side. The rise of AI fake news, right? And these bots, of course, are also examples of AI. Um, and that hallucination, images are made up, um, and people can easily, suppose there is a crisis in Manipur, people can easily make up images and present as that to be the case. The interesting thing is that as the AI creates harmful impact or creates problem, you also need to develop stronger AI to counter that. So there is a cat and mouse problem. And on the right hand side, for example, we had a paper talking about building trustworthy neurosymbolic AI system for consistency, reliability, explainability, and safety. So I'm going to talk about some of these today. And there are many other challenges that we'll discuss as we go along. Another issue is that what is generative AI currently being used for, where it is very successful. So the paper that I mentioned here, Consent in Crisis, that analyzed 1 million ChatGPT queries. And you can see that the kind of application it has been used for on the top left. Top use case is creative composition. So if you're a content editor, this is great. Second most popular is sexual role playing. Third, other common use cases are brainstorming, planning. For example, you could say, I am visiting this national park, help me create a 2-day or 3-day plan for me, and it can do very good job. You may then customize some explanations, it does well. But these, as you can see, these are not really decision making queries. They are not the queries that can lead to a lot of actions in targeted cases. Yeah, action in the context of visiting a national park, yes, but not in many other cases, not in, let's say, on a factory floor. So for the high quality business use cases, industry use cases, there is a lot to go. Now, what are the risks associated with this? The risks are lack of transparency. AI models can be unpredictable. Accuracy issue. You can never promise that the AI system will not make up the information. That is the nature of the AI system. Basically, the generative AI is exceptionally good for memorization and for the task that can be solved with memorization and pattern matching. Bias detection, is a problem. Intellectual property risk, because these AI systems would take the data that you give. Cybersecurity threats and sustainability concern. Of course, Microsoft just paid for 3-island nuclear plant that will cost $1.5 billion to just restart, and then $1 billion a year. So there are many use cases. Google's AI chatbot Gemini tells users to please die. or you are a waste of time and resources. That kind of stuff happens, and many other issues that may come up in terms of asking to use glue for pizza. So what is the solution? Where do you get the solution? To start off, that is these three very important terms: instructability, grounding, and alignment. And there are a lot more. Instructability is about the fact that AI system that may be, and I'm putting it very simplistically because there's only so much time I have. But AI system like the generative AI system is trained on massive amount of data, but it may have been last trained in 2023. It does not have latest information. That information can be given from outside, and there are also more feedbacks and additional learnings that humans can do. RLHF is very well known, but there are other emerging techniques that would provide AI system. So don't think AI system as knowing it all, and let the humans or other technological way, let us provide additional information in technological way. Grounding is another thing where you make AI system aligned with the or connected with or supplied with the real world concepts, um, and then alignment itself, that you make AI system behave in a more value centric manner, uh, in a way that is consistent with human values, with laws, with regulations, policies, guidelines, and such. Um, so we've been working on neurosymbolic AI as a way to do that, and there are a whole bunch of things to take care of: consistency, reliability, explainability, safety, trust, to make applications, important applications, uh, you know give you what you want. Just another example is here is that uh, you ask a generative AI system to explain the answer, and the problem would be that it'll give you an answer that is not very specific in the context of user knowledge, human knowledge. Let's say that a clinician asks you questions that relates to uh, depression, and if you if 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 you want explanation as to why the AI system comes up with what it does, it needs to incorporate domain knowledge such as PSQ9. These are the nine different question considerations that um, um, goes through. For example, patient's appetite, or patient's energy, or sleep problems, or suicidal thoughts. So you have to formulate your answer that incorporates those specific domain considerations. Okay, let's quickly look at challenges with generative AI, and we are going to talk about a subset of these. So today, we'll talk about hallucination, AI generated content, misinformation, and one more. Um, First problem is it AI or human? So what has happened is that today the generative AI is so good at natural language generation, or for that matter, image generation, that at times it would be very hard to say whether it was generated by human or machine. And if you think about regulations, so suppose a regulation says that you need to identify um, content that is human generated or machine, where it is machine generated. Well, that would be very hard to do. Many times, when students use chat gpt and answer a question, it may be impossible for a teacher or instructor to say whether it is ChatGPT generated or machine generated or written by human, right? Um, we had a paper in EMNLP, that is one of the top two conferences in NLP area. And this paper, you can see at the bottom, won the Outstanding Paper Award. And here we looked at various factors, uh, bustiness and perplexity, stylometry and other things, and we compared 15 large language models. And as the models become more as we develop larger models, it has become more human like in content generation, and hence harder to detect if the
Poetry.
content is AI generated or human generated. So this is a very important problem. Um, in the context of AI, it is possible to generate the images, some of the images. You can see the image of Pope, and that by doing visual paraphrasing, it's a kind of attack you can do on the images. You can change the images, morph it, and to look different, but it will be impossible to say whether it was human generated or machine generated. So that is a very challenging problem that you have to solve. And 90% of all online content could be synthetically generated just by in less than 2 years. So there are techniques that we have been developing. One of them is called visual paraphrase, Pikavi, visual paraphrase, a text safe and distortion free image watermarking technique. And this is a work in progress, but there are variety of paraphrases on the image you can see in the picture, and that in the image you find a particular part of the image that changes the list with the paraphrase uh, attack. And then what you do is to then that region which is stronger region, you put the watermark, and this is the way image with salient region that you would watermark, and makes it and then you encrypt the parts, and put it into the header file, so only people with the right permission can look at it and decide whether the image is uh, machine generated or not. So uh, the next major issue is information misinformation, deepfakes. So here EU has a code of conduct against hate speech, but evaluation is very hard. You can see the image that I created for just by giving the prompt about Elon Musk marrying Kamala Harris. This was done before Elon Musk became very busy with supporting Donald Trump. And the text, same about the text. So we did that. It's very easy to use AI models to create misinformation. And 2 years earlier, a survey said that 10% of the social media user use AI to uh, create fake misinformation or fake news, and 56% knowingly forwarded this. That's a huge problem that we face. Now, and so we have some papers in this area, and we also run a series of workshops where we create a very large corpus, and have shared tasks and invite people to participate in the competition. Here is a very interesting example, with regards to multimodal fact verification. There's this post you can see on the left hand side where it says, "I got to work with Magic Johnson last month when he came in the hospital, in our hospital to donate blood." And you can see there is even a photo, right? Well, it's actually fake. And one of the things that we have done is to build this 5W based explainability. So we ask who claims what is the claim, when was the claim made, where was the claim made, and why the claim. And then it automatically gets the answer for many of these things. It's not a perfect tool, but compared to the fact checkers, let's say news organization, this does far more activities. The way I would say is that this could be used by fact checker to substantially improve their productivity. Now, how would you solve this problem? And here, this is a very important point, that I would like to explain you. The way to solve this problem is to identify the fact that Magic Johnson is HIV positive, and HIV positive people cannot donate blood. So with that, then that is the knowledge, and you have to find this applicable contextual knowledge and apply that. So even the most important point I want you to take away here is that there's no way a generative AI system can solve the problem with its world-class statistical processing, right? I mean, it creates this exceptionally good information from the data. It learns from the data, from the training data, but it will be missing this knowledge. And so we have to bring in this knowledge. That's why you can see here knowledge infused visual language modeling. So this is the kind of work that we've done, and NSF has funded a project just to work on this kind of problem. And so here we are helping Neurosymbolic AI solution. Next is a hallucination, and the kind of that this became the 2003 word of the year. By the way, it will be, I hope some of you know what is the 2024 word of the year. It is brain rot. That's very interesting. Let me not diverge here. But when AI hallucinates, it produces false information, and that such a thing could be easily done by a system. And now this kind of hallucination can happen even in the visual content. So for example, you're seeing some of these here clips, and say temporal dysmorphia is the kind of things that AI system generates but could not have occurred when you look at the order by time, or in the subject multiplication reduction, you may see that let's say a human just disappear from the image, right? Something like that doesn't happen. So these are the and this was just generated last month or very recently. With ChatGPT, um, uh, there is a lawyer that used ChatGPT, and he was found to have used the ChatGPT, and he could, the interesting thing is that in one of these cases, ChatGPT created even the past cases. So in a legal brief, you have to say you're building an argument based on the past rulings, and the ChatGPT simply made up the rulings that were never there in the real world, right? So this is a huge problem. The lawyer was found and countersued. So characterizing this hallucination is a major problem, and we developed a classification for that. You see on the left hand side, and then we created this hallucination vulnerability index, and as you can see, there is a higher hallucination as the models have become more complex, right, from bottom to top. So larger LLMs without RLHF are prone to both orientations of hallucination and in other things. So, and there are many other details that right now I'm not going to talk about. But this paper also was nominated for Best Paper Award, and there was a very big article in a piece in Washington Post discussing this work, and our student was interviewed for that. Okay, so by now I've shown you a whole variety of problems that occur, the whole variety of challenges with the generative AI. This is very um, uh, so we are at a stage where AI is doing some wonderful work. Certain problems it solves very well, but um, there are what I will do is now to go towards a class of problems that we can still not solve, solve very well. And what do we do? So again, um, how the AI is moving. We believe that now we are entering the third phase of AI, and we believe that is through this neurosymbolic AI. So the point here is that your symbolic AI of the last century, you have statistical AI for this century so far, more or less, and that we are entering this next phase where you might say, well, okay, we for 20-25 years we really made huge progress in the second wave of the AI, and the third wave is what we are entering. And why? And going to try to explain, what are the unique things about this next phase, what we are doing uh, as our contribution to that next phase. So here are some of the challenges that we address. Um, I'm going to pass that. Um, so now we are talking about this word neurosymbolic AI. So we basically have the symbolic part. You see here in this image, symbolic part is on the right. One form of representation of symbolic information is knowledge graphs. This knowledge graph word recently DARPA published, sorry, not Gartner published a piece where it touts a huge value of huge importance of knowledge graph as we go forward. And in the left hand side is your statistical AI, natural implicit parametric knowledge representation. And now the idea is to combine the two, and you combine this um, that in a way that may also involve human expert, for example through instructability, right? So what you do here is um, and this kind of technology is going to be much more valuable for the class of application that generative AI cannot solve well, which I call this decision making or action taking applications. There's another you can see there the system 1 and system 2. This comes from Daniel Kahneman's who won the Nobel Prize in economics from his work going fast and slow, and where system 1 is perceptual, and the system 2 is cognitive, in my way of thinking, and you need both of them. So our human brain can immediately understand certain things, like a ball coming at you and you duck to make sure that ball does not hit you. But then human also, that is system 1, but human also takes deliberative decision making. Plants, I want to apply for a top a very good a good university for my PhD, working under a top professor. Well, that's your longer term plan, and you make series of steps to go there. So this neurosymbolic AI would have a lot more play in combining the things that happens for this different kind of task to make a stronger task. Just like how human brains uses both of them. A slightly technical slide, but what I'm going to here say is overall, there are many ways to combine, um, the statistical techniques, the neural networks with knowledge. And the knowledge, by the way, can also not only be in a form of knowledge graph, but in logic rules, for example. There's also something called physics-inspired, neurosymbolic AI. So here there are a whole bunch of specific algorithms, and some of them are developed by my team, and there's some by others. And I have other keynotes that go that specifically discuss and compare these algorithms and give you insight into how knowledge is used to modulate the attention mechanism or loss function in the neural network. But there are once we classify these algorithms in shallow infusion, semi-deep infusion, and deep infusion. There is also a fourth kind which called knowledge elicitation. Now, here what happens here is that you create your feature abstraction layer from the data, and from the knowledge graph you create representation for knowledge processing and understanding, and then you combine in multiple ways. That plus sign here stands for many possible techniques, and then you figure out a way to use the knowledge appropriately in many different ways. That is the plus sign. And then you may have to make multiple queries, combine them. So there is a term that is becoming popular these days called agentic workflow. So you may be able to have series of activities you do to get those results that you want to. Let's say, do for a doctor to develop a treatment plan or diagnosis plan using AI. So here is one algorithm that we developed. Is called TDLR, and it's an example of semi-deep infusion. And the bottom, you'll see that there is a self-attention matrix A, and then there is B, which is the knowledge semantics encoder. So that is coming from the knowledge graph. And then there is a matrix operation that combines the two. And then that is the one that drives so basically changes some behavior in the neural network. And then because of the infusion of the knowledge here, you can see on the bottom right, the system understands variety of terms that relate to World War I. The terms may have very different representation or syntax, but the system is able to understand that these terms mean something same. But and the improvement, as we show in the paper, is largely due to the fact that we are adding the knowledge to the traditional generative AI techniques. So obviously I'm not going to go through these details in the paper, but you can see that there are two interesting takeaways from our work. Knowledge context leads to performance gains with similar models. So these are models of similar size and all that. But knowledge context leads to performance gains with smaller models and smaller data set also. Even with the smaller data set and smaller models, we can compete with larger models. Right? So these but large and TDLR based comparisons. So that kind of things you can do. Another thing that we do very well, that you can do very well, is that um, here on the left hand side you see the knowledge relevant to depression. And if you use a, let's say, clinical T5 model, and ask it to explain how what is the reason for a particular classification, um, then and what are the depression signals that is in the text. It shows you that those red text, but they are not very meaningful for a clinician, for a decision maker. Instead, um, on the bottom in this green, we show the texts that are far more meaningful, like feel lost. So, and there is a PSQ9 concept of feeling hopelessness, with corresponding SNOMED term and such. So the system understands that and maps, the text to the concepts that are relevant to humans, like in this case, clinician. Um, now, for solving decision support assistance, what we argue is that we need to use data, need to use knowledge, and we need to use human expertise, um, and that also not for just improving the quality, but also explainability and safety validation to feel this system in the real world. We want to also have engineering benefits like reduced parameters, lower computational cost, and lower energy use, and then other business benefits. So as we started looking at some of the substantial applications, we found that there are many expectations and requirements for any system, for an AI system, for so that you can really consider this AI system to be robust, to be uh, more intelligent, and to be trustworthy. For all that, you see all those hashtag items. Those are all the items that um, we need to address before we can really have this so-called, what we call as robust, intelligent, trustworthy AI system. And we have done work on most of them, and the remaining one, is a work in progress. So it's a very exciting research area. Each of these hashtag item can be a subject of a PhD dissertation. One of the students just did her PhD proposal defense on analogy as an example, and another did already on causality. So there are a bunch of articles that I mentioned. You can get the slides, Google the titles, and get to them. And it's a very exciting research agenda. But it's very important to sit back and ask how much of this is supported by the best of the generative AI system today. And the answer would be they largely suffer. They are largely not prepared for all of this. Now, for that, now what I'm going to do is to show you an application. The application, we have the important thing that I want to convey to you is that the real world application that have real value, such as value in making a decision or taking certain action, are inherently a lot more complex than, and particularly enterprise application, a lot more complex, and have required a lot more guarantees in terms of those robustness and trustworthy features that compared to, let's say, what general AI system can do. So the AI needs to evolve to support them. Let me play a video. I'll play this long video and then one short video. So let me see. Can you hear? hope you can hear.
Yes, Professor C.
Sir, the video content is not audible or visible.
Video content is not audible or visible. Okay. I don't know if anybody knows setting.
You might have to present your entire screen, sir.
I'm presenting the. Oh, am I not? I'm presenting the screen, but let's see. Let me one try. Mm, mm,
Yeah, you might have selected the window,
okay, let's see.
presentation window.
Is it working now?
No, sir.
Yet.
Professor C, probably you might have to like stop presenting and then start presenting again with sharing the whole window screen. Sharing the entire screen.
Let me see. Yeah, no, I'm sharing entire screen. So I'm using this here on the bottom right, this thing for entire screen that I'm doing.
Okay.
Mm.
So maybe there's a link over here which says please play on YouTube. Do we like?
Let me try that. Let me. Where do you see the link on YouTube? Playing on YouTube?
I see it at the bottom of the slide.
Oh,
Probably.
slide. Okay, okay, okay. Yeah, that's what you should do. Right, right. Um, mm, Let me do this. Here it is. And any success?
Not yet.
Okay. Okay. So it looks like uh, the in the Meet. I know this works in Zoom, but in the Meet, I don't know how to make it work. Um, okay. Here's if anybody wants, I'll put the link in the chat, and you can see whether you are able to.
Yeah, that should work.
Okay. I'm going. Yeah, where is the chat? In call applies. Yeah. I don't see chat option here.
It's next to the people icon. There's a like a chat box, bottom right.
Yeah, in this. Let me see.
If you want, you can send it to me through mail also. Maybe I'll open it up through mail.
Let me do that. Okay, I sent it, and I'm going to continue with the presentation. We'll play the video a little bit later. So, are you able to see my slide right now?
No, sir.
No. Okay. All right. So hopefully you can see the slide now, right?
Yes. it's coming up. Yes.
So
Every meal impacts your health. So why
Oh,
not?
the video is working.
okay, let's then go ahead and play the video, and I'll stop sharing.
No, you when you played this, I think it was like visible to us.
Oh, okay, let's see.
Yeah.
What is the time? Let me do short video.
Well, now we cannot hear Professor Seth.
Okay. Okay. Let's move on. We can play at the end. You will see the slide, right?
Hello. Today, we will be presenting a demonstration of the Allure Collaborative Rubik's Cube Solver. Our system consists of an
Hello.
automatic solver
everyone.
Today,
based
I'll be
on
presenting
generated
a
work
demonstration of
So here is a. You remember earlier I was talking about. You're able to see my slides, right?
Yes, sir.
So earlier I was talking about how do you get meaningful insight into how let's say why the AI system says something or recommends that this is the answer. Here you can see visually that on the text, which is a text um, from Reddit, we are connecting back to the knowledge graph about depression. And here you are able to map the terms into and the terms you see they're not syntactically the same term, they are semantically related terms, and by being able to map.
So we cannot hear you.
Yeah, now
Yeah, there's some background noise. Anurag ji, can you please mute yourself?
okay, can you hear me now?
Yes, sir.
Okay, so what you are saying is that the system is able to understand how the what are the concepts in the knowledge graph or human knowledge that text maps to. And you can see there's not just syntactical mapping, it is a semantic mapping. Here there is a process knowledge or a knowledge coming from CSSRS. This is one for suicidability, and here given a text, uh, you are able to answer the questions: wish to be dead, non-specific active suicidal thoughts, active suicidal thoughts, and you're making the system interpretable for clinician and patient. So for example, compared to LLM, using the kind of models that use the knowledge, you get far better results. And even I would say that 70% result is not yet um, good enough, but I think it is getting there. A very important example here. You see that earlier there was an example where a chatbot said you die or you should die, that kind of thing, right? Very unusual or very unsafe interaction. So here is an example where the chatbot asks, or Copilots asks, do you feel nervous? And human answers something, and then the chatbot has to ask multiple, other questions based on that answer. Here, the chatbot needs to understand that a certain question could be unhealthy and hence unsafe. So in this case, because of the use of knowledge that involves this, what we call a safety check. So knowledge infusion using medical questionnaire, that technique that we have developed, you would understand that self-destruction is something you want to talk about. So it will ask the questions that are clinically safe, right? So this is a very important part on capability that the system need to have. Analogy is a now one of the things I mentioned was robust, intelligent. So analogy is a very important capability. It's critical for designing more intelligent AI system. It is useful for as a educational pedagogy. We often explain things with analogy, and it also supports innovation where you can transfer knowledge from one domain to another. So there are many types of analogy, and we define a taxonomy of analogy from lower level to higher level, and then so here is that layers of analogy or taxonomy of analogy, starting with simple lexical analogies, syntactic analogies, or sentence level, semantic analogies, and then pragmatic analogies. So here, something on the cyber security text is mapped to Trojan horse related text. So you can use something from mythology to understand about cyber security, and it uses a lot of different. It has a lot of different components: statistics, syntax, semantics, and pragmatics. So here is an example of taxonomy, and it has a number of concepts. For mythology, you have all these concepts you can see on the right hand side, and all the relationship you see, and the cyber security has similar things, and your job is to be able to map the two and make sure that this comprehensive, complete analogy. So something like this cannot be done without having the knowledge, right? So there's a lot of detail that I'm going to pass now. I see the time. Okay. Another very important area is causality. So LLMs cannot reason beyond correlational pattern in the data. So that cannot be a true causality. So so these kind of things is very critical, and machine learning models are trained on observational and correlation data and correlation, but they don't get through causal structure. So it will be very difficult for them or impossible for them to identify unobserved, rare, anomalous out of the distribution events. So we are developing this causality thing, because a next generation of causality where we can incorporate a whole variety of knowledge, perhaps of space, time, also together to support this. So current AI fail, in causality. Let me, they have a hard time distinguishing between correlation from causation, and they can't reason beyond data, what they have. So in the causal neurosymbolic AI that we have done, we use causal representation and knowledge graph to create this so-called causal neurosymbolic AI. And then you can also do the reverse, where you can use symbolic representation and infuse that knowledge into cause Bayesian. So on the left hand side is the Bayesian network into the traditional Bayesian network, and make the system smarter. So here's one example. Here you see the smart manufacturing rocket assembly. You see the sensor data it will provide. Now you can see that there are a whole bunch of ontologies or knowledge graphs that are necessary to make sense of all that data. So traditional technique would be to use this data and apply AI to do your causal AI. But here what happens is that you are applying the knowledge to make the data more meaningful by labeling the entities in relationship. And you can see there are dynamic process ontology, there is a scene ontology, there is a causal ontology, and then there are existing general purpose ontologies. All of these are used to create a knowledge graph, and then on that knowledge graph you can do the queries. Given a no-nose anomaly, which frame and assembly cycle it is associated with, right? And from that you can get very much more meaningful information from your data. What happens is that the traditional causal AI methods will give you all these links, but you would not know the links and the meanings for the links and when you should traverse the link. So what we have to do here is to make those links meaningful and then traverse in context to really get a deeper understanding of what's happening and why something results into something else. Okay, so I'll just leave it at that. Another example is scene understanding in autonomous systems. So in this case, again, what happens is, suppose you get a ball on the street in a neighborhood. Now, a traditional AI model or genetic AI model will see the ball, but a human would reason that if it's a ball, there is a possibility of there's possibility of children around. How would you get that? Well, again, that kind of further intelligence in about this understanding the scene comes from the use of knowledge, and there's a lot of work that we have done in that area. So here it shows that there are a whole bunch of issues in scene driving, and that the use of this knowledge graph and neurosymbolic AI technique improves upon all of those things. So in the MTSS, there is this 3-tier system. So thing to keep in mind is that many of the system, in this case behavioral health system, are pretty complex. They are related to let's say providing behavioral mental health support to school children, and it involves a whole kind of community of people. It involves family, counselors, administrators, and educators. And counselors may be a school level counselor and district level counselor and a nursing person. So they have different jobs to be done, and that there are different paths to supporting somebody. It may be a tier 1 support where you have general core instruction, your tier 2 support where you are doing targeted interventions, and tier 3 support where you do intensive one-on-one physician to patient interaction, right? Which of the interactions should be offered to which student for at what time? These are all the complex questions. So here is the view of the MTSS system, and it has many components, and it maps to some of the needs. Here you can see I'm showing that there is a there is a need for grounding, there is a need for alignment, there is a need for instructability, and there is a need for reasoning on the top right. All of these are necessary. These are the kind of things that we have not seen generative AI systems currently do, and that's what we need to do because these are real world applications. You need to support them. Okay, So here, there are a lot of functions that you have in the middle, and all right. Next is a food computation, personalized nutrition application. So it's a very complex domain. It needs multi-contextual reasoning. I'll explain that. High-stake domain that requires robust and trustworthy AI, and you need user-level explanations. So you have an image. This is the food that the patient or somebody is nutrition seeker is interested in analyzing, saying, can I should I eat this? And to do that, this image, there's all these issues of image and the segmentation and understanding and all those things that we do, and their generative AI is very useful. And some of those tasks can be done very well with image processing system of today. But then there is a lot of other things to be done. So you need knowledge sources of various kinds, and you also need the recipe text and images. In this case, so can I eat this requires a lot of reasoning, and it may be that, well, you have potato in this, and it has a healthy carbohydrate but high glycemic index. Canola oil is undefined. Quite likely it is canola oil. Undefined is a good fat. Deep frying, trans fat. Potato plus frying is vitamin A and C lost. Allergen, and you can see the sources of the knowledge: WebMD, US FDA. Allergens, dairy-free, nut-free, and daily value calorie within limit. And then you get the results, and it says, well, you can have alternative recipe, or you can have revised recipe. Say, do air frying instead of deep frying to improve the to make this more acceptable for your nutritional need. So many things are involved in this process, and here I'm showing you a piece of that. I guess this slide has too many things to discuss here effectively, but what I'm want to make, the point that I want to make here is that you have multimodal processing. You have knowledge graph that have knowledge related to all of these components. You have disease specific knowledge graph. You have cooking taxonomy. You have ingredient substitution knowledge graph. And you have understanding of all of those cooking process, and then you can see the model there. So entire system is quite a bit more than just what the model is. So finally, you have the model that will do certain computation, and then support the application. Okay. So and then there's yet another thing about attribution. Can you say what is the basis of, what is the source of the information that AI system has sent? You remember that case where a lawyer asked ChatGPT about creating the legal brief, and that and the AI model just made up all the citations. Well, that you want to prevent that. So you want to be able to attribute exactly what are the source of information that you rely on, and that is the and here we show how how using the neurosymbolic approach we can address this problem. Okay. So now I'm going to make final points. We talked about value-inspired neurosymbolic AI, and there are other various terms: human-inspired AI, civilizing AI, constitutional AI, and they vary a little bit. But the human-inspired AI and civilized AI are the terms that we have coined. So there are many values, that social values, cultural values, individual centric norms, and to make AI systems a healthy component of human society, you really need to pay attention to all of those. That's what we discuss here. And that then there needs to be effective way to combine those values. So one example I already discussed was about the safety, that you do not want to ask about self-destruction. But there are many other example I discussed was explainability, and explainability for a particular user or class of users. And then there are many other types of value systems that you have to bring in to really create a useful an AI system that fits into the human society. There is a broad outline of that here. So these are my students and my immediate team, and there are a lot of sources for support here. Okay, so with my budget of time, we have a few minutes left. In case you guys want, so we have two options. You can play one video if you're able to do that.
Yes, yes.
Yeah.
Sure. I can present the video. I can play the video.
Yeah, please.
Okay. Is my screen visible?
Yeah.
Yes.
Why not make it?
I'm not able to hear, but hopefully others are.
No, sir.
No, it is not audible actually.
So was it visible, Nikunj?
Yes, it is visible, but not audible.
Not
exactly.
audible. All right.
Yes.
So maybe let me try this one also. Just check this one.
No, not audible.
Okay, if that's not the case, we can we can send the share these slides.
Yes.
And I'll send the link to Dr. Singh, and then
Yes.
Yeah,
Yes.
I'm also like putting in the links in the chat box. So anyone who is interested in looking at these videos, yeah, I've put in the links in the chat box.
Yes. Yes.
So the floor is open for participants to interact with Professor Sheth, and if you have any specific questions, participants, you can unmute yourself and interact with Professor Sheth.
Yeah, can I go ahead with a question?
Yeah, sure.
Namaskar, sir. Sir, so I am a research scholar and I'm beginning to work in the same domain as yourself. And I have a question related to what is your opinion on detectability of AI-generated text? Since you showed us the paper and the index, do you think it's really feasible, or do you think there be some approaches that we should take in order to make it, maybe we can narrow it down to some domains or something where it becomes feasible. So what is your take on it?
So basically, watermarking techniques have to be developed. We are working on those techniques. Particularly the research associate professor Amita Das is coordinating those efforts, and we think that we can develop some watermarking techniques so that if the image is generated by AI system, that it will be watermarked, so you can say it is AI detectable, AI generated. But in the next sometime, I do not think that it will be possible to detect. Right now, I do not think any company has a solution for detecting whether the text or image or video is AI generated or not. So maybe those techniques will evolve. So it's a very good research topic. So if you're working on that, great. Please do work on that. But it's not going to be easy. But here, for example, you'll see a whole bunch of effort has been made in watermarking.
Okay. Okay.
Any other
Thank you,
questions?
sir.
Dr. Biswa Senapati has a question, Professor said, that for data imputation in the dataset, GAN and LLM are used by the researchers. Which one is better?
Say something more about what do you, I mean, I really don't know. That's something. Yeah, not something I would be able to guide you on. I mean, first of all, when you just say even LLM, I mean, this is such a wide variety. I assume you're talking about transformer model, but all of the LLMs are going to create high dimensional space. Yeah, the number of dimension will change, the number of so the complexity, number of layers will change. All of that will be done, but in the end, going back to what the data was is not possible. It's just the nature of the technology. I mean, the same way that hallucination is a artifact, is a feature of this technology. So unless and you really don't have control. All the top AI researchers will also say that it's largely a black box. You don't really know exactly how you got to that. So I doubt that you can do this well.